Sullivan. My project is on advanced sales prediction methods with data science. My background is in lower middle market private equity, and I chose to learn data science looking for additional ways to gain an edge on enhancing performance of businesses. Outside of work, I'm typically chasing my 3- and 5-year-old sons. The case study we'll look at today is codenamed eChalk. They are an acquisition target of a private equity firm I'm working with. eChalk's primary business is to supply and install smart school supplies, such as a digital whiteboard seen here. The primary customers are K-12 schools. The data we're analyzing came from 6 years of QuickBooks customer transactions. This is very valuable as it contains customers' name and state, invoice date, and invoice amount. The transaction data allows us to build a customer cohort chart where we group customers by the year of their first purchase. When the cohorts are stacked vertically, they show the annual sales for the calendar year. Looking at 2020, we see how stacked colors make up the 15 million in total sales. It becomes clear the bulk of sales are coming from long-term customers. This makes sense, as the head of audiovisual at a middle school has other things to do than shop around for new vendors. Another interesting item is how 2016 customer cohort doubles in sales 4 years later, which gives us a clue how long it takes to reap the harvest from long-term customers. Lastly, there are 3 sharp declining slopes from 2019 to 2020, which raises concern about churn. Analyzing transactions can help build really granular level details. There is signal in these busy details. The company is acquiring better customers, shown in the middle highlighted row, but in the top highlighted row, the number of customers per year has been declining. So the question is, are they acquiring enough customers to overcome their churn? Looking at customer churn, one can see a churn rate of 68% after the original purchase. This initial churn highlights how only a third of customers make a second purchase. Let's walk through the prediction process. We transform the raw data into retention, purchases, and spend data set. We use a buy to or die model, which uses the negative bimodal distribution to predict number of predicted purchases. Same distribution is used again to predict probability of life for each customer. Then the gamma-gamma distribution is used to predict average spend for each customer. Combining all 3, we can predict customer sales. First, we fit and predict purchases. From our analysis, we found the average time between purchases is 17 months. Therefore, we split the data into a 4-year calibration data set and a 2-year holdout for cross-validation. This model fits pretty well up to 3 purchases, but the model overpredicts on 4 more purchases, mainly due to the length of time between purchases, 17 months, and only having a 2-year holdout data set. Next, I use the model to predict probability of life per customer. Okay, this is an interesting chart and an important chart. Essentially, the negative binomial distribution statistically shows a simple concept. The more often a customer purchases, the more likely they will remain a customer. The chart shows that with every purchase, the peak of the line increases and the slope of the line becomes more gradual. Let me show you how powerful this model is. This customer wasn't active for 16 months. Personally, I would think the customer is gone, but the model predicts a 30% probability the customer will purchase again. This buy to or die model is developed by University of Pennsylvania's Wharton Business School and has a Python package called Lifetimes. The links are in the footnotes below. When predicting, I selected a probability threshold and some probability of life to predict customer count by cohort. Next, I found the average of predicted purchases by cohort. Then I combined the 2 predictions to get the predicted purchases by cohort seen on the right side of this slide. And you can see them more visually in the customer cohort chart. This also shows a gap we need to overcome with our new customer acquisitions. So due to our large churn rate, our average sales per order for both existing and new customers need to continue to grow. They actually need to outpace the 3-year averages in order to achieve the same sales trend. Given the tailwinds of digitalization of schools caused by COVID, there is a scenario where landing a few large school district size orders would increase average sales order amounts and continue the company's current trajectory. This advanced approach helps us to identify key risks and places to investigate. I believe there's significant value in this buy to die model overlaid on top of a customer cohort chart. I hope I've shown that today. This model can be used for scenario planning. It can be combined with other models such as random forest to predict average spend per customer or find common features. And what I really hope to do is build out the functionality to get a customer-based corporate valuation. That concludes my presentation. I know I've covered a lot, so please ask your questions.